thought I would record a short video with some examples of solving linear equations. So let's work through these. Remember, linear equations are first degree equations, meaning the highest exponent power on the variable is 1. So on this first equation, remember, anytime you're solving an equation, you're trying to find the value for the variable that will make the equation true. And the process involves getting the variable on a side by itself. So if there is not a variable already on a side by itself, you've got to undo the stuff that's there. So if we're looking at this left-hand side, it has x plus 3. So we've got 3 being added to x, and we want to get x by itself. So how do you undo addition of 3? Well, to undo addition, the opposite of add is subtract. So we're going to subtract 3 from both sides. Because remember, whatever you do to one side, you have to do to the other. So if I subtract 3 from the left, I've got to subtract 3 from the right side. So what does this give us? We bring down our x. 3 minus 3 adds out to 0, and 0 plus x is just my x, equals 2 plus a negative 3, or 2 minus 3. Remember, that's the same thing as 2 plus negative 3. The signs are different, so we get the difference in the absolute values of the numbers. So the difference in 2 and 3 is a 1. 3 has a larger, negative 3 has a larger absolute value than 2. Negative 3 had a negative on it, so our answer is negative 1. And if you want to check this, plug negative 1 back in for x. So we would have negative 1 plus 3. And we want to know if that's equal to 2. Well, negative 1 plus 3, the signs are different. I'm adding, so I get the difference in 1 and 3. It's a 2. 3 is bigger than 1. It was a positive 3, so negative 1 plus 3 is 2, and 2 is equal to 2. So that lets me know indeed that negative 1 is my solution. On this example, we're again solving. We're trying to get x on a side by itself, but this time x has 4 subtracted from it. So what's the opposite of subtract 4? It is add 4. So I will add 4 to both sides of the equation. On the left, I bring down my x. Negative 4 plus 4, those are opposites, and opposites add together to give 0. X plus 0 is just the x. So x is equal to negative 3 plus 4, which is 1. And that's the answer. Of course, if you want to check it, plug 1 in for x. 1 minus 4. And I want to know if that's equal to negative 3. Your subtraction rule says change the subtraction sign to addition, change the sign of the number being subtracted. So this would become 1 plus negative 4. And again, we want to know if that's equal to negative 3. The signs are different on the 1 and the negative 4, so I get the difference in, ignore the signs, but 1 and 4. Difference in 1 and 4 is 3. 4 is larger than 1. 4 had a negative, so my answer has a negative. Negative 3 does indeed equal negative 3. So it checks, which tells me x equal 1 is the solution. Okay, this time we have 2 times x, or 2x. Nothing added or subtracted from it, and that's equal to negative 12. So to get x by itself, I need to undo multiplication by 2. Well, what's the opposite of multiply? If you think divide, you're exactly right. So I'm going to divide both sides by 2. Again, whatever you do to one side, you have to do to the other. So 2x divided by 2, the 2's would divide out, leaving you with x equals negative 12 divided by 2. It's a negative 6. 12 divided by 2 is 6. If you're dividing and the signs are different, your answer is negative. So negative 6 is my answer. And if I wanted to, I could check that by plugging negative 6 in for x in the original equation. The original equation was 2 times x, so this would be 2 times negative 6. And I want to know if this is equal to negative 12. Well, 2 times 6 is 12. I'm multiplying, the signs are different, so it's a negative. Negative 12 does equal negative 12, so negative 6 checks, and that assures that that is our answer. Let's try another one. This time we have negative 2x is equal to negative 2. So keeping in mind we're trying to get x on a side by itself, it only has negative 2 multiplied with it. So to undo multiplication by negative 2, we're going to divide both sides by negative 2. Well, negative 2x divided by negative 2, those negative 2's divide out, leaving us with x equals negative 2 divided by negative 2. 2 divided by 2 is 1. The signs are alike, so it is positive. So x is equal to 1. Let's step things up a little bit. On this example, we have 2x minus 3 is equal to 6. Again, your goal is to get x on a side by itself. So we first need to start by getting the x term by itself. So the 2x needs to be by itself, but right now it's subtracted by 3. How do you undo subtraction by 3? Well, the opposite of subtract is add. So we will add 3 to both sides, which gives us 2x. The 3's add out as opposites to 0, and 0 plus 2x is just 2x. And this is equal to 6 plus 3, or 9. We have the x term on a side by itself, but we still don't have just plain x by itself. Right now, the x is multiplied by 2. So to undo multiplication by 2, we divide both sides by 2. So I'm going to divide the left side of the equation by 2 and the right side divided by 2. With the 2's here, we'll divide out, and you're left with x equals 9 divided by 2. It's 9 halves. And you can check this. Plug 9 halves in for x, so this is 2 times 9 halves minus 3, and we want to know if this is equal to 6. Well, these 2's will divide out, and 1 times 9 is 9, so I have 9 minus 3 is equal to 6. Well, 9 minus 3 is 6, so it checks. So that confirms 9 halves is the solution. Let's try another one similar to the last one. We need to get the term containing x on a side by itself, but that negative 4x has 6 added to it. So how do you undo addition? The opposite of add is subtract, so we'll subtract 6 from both sides. Now I'm subtracting it from the left side of the equation and from the right. If you wanted to, you could think of this, some people write it like this. Okay, so there's my original equation. I want to subtract 6 from both sides. So some people will do this. So adding like terms on the left, I don't have anything to add with the negative 4x. I would bring down negative 4x. The 6 minus 6 is 0. So that would be plus 0 equals negative 8 minus 6. We're adding, so remember you could rewrite that as negative 8. Change the subtraction sign to addition. Change the sign of the 6 to a negative. I'm adding. The signs are alike. So I add the numbers. 8 and 6 is 14. and I keep the sign. So negative 4x equals negative 14. So I'm going to go back up here. If I subtract 6 from both sides, I have negative 4x. 6 is added out, so I'll only have a negative 4x on the left side, and negative 8 minus 6, so negative 14. Still don't have x by itself. It's multiplied by negative 4, so to undo multiplication, you divide. So I need to divide both sides of my equation by negative 4. Well, on the left, the negative 4's divide out, and I'm left with x equals, negative divided by negative is a positive, so that's 14/4, which reduces or simplifies to, we'll divide into 14 and 4 and give me 7/2. Okay, what do you think the first step would be on this problem? Trying to get x term on a side by itself. So if you think, oh, I need to add 1 to both sides, you are exactly right. So we'll add 1 to both sides, which gives us 5x equals, because the 1's add out, a negative 11 plus 1, that's a negative 10. The signs were different. The 11 had a negative on it. The 1 is understood to be positive, or you could think of the plus. So they're opposite signs, so we get the difference in the absolute values of the numbers. Remember, the absolute value of negative 11 is 11. The absolute value of 1 is 1, and I want the difference in them, and that's 10. But which number had the largest absolute value? The negative 11 did. So we keep the negative sign. So 5x is equal to negative 10. We want to get x by itself. It's multiplied by 5. What's the opposite of multiply? Divide. So I will divide both sides by 5. 5x divided by 5 is x equals, left off my negative right there, negative 10 divided by 5 is negative 2. And of course you can check all of these by plugging the value you find for the variable back into the original equation to make sure it gives a true statement. Here's another one. What do you think would be the first step? If you think, I've got to get rid of those parentheses, you're exactly right. But can you do anything to simplify what's in the parentheses, the 2x plus 3? If you're saying, no, I can't add those because they're not like terms, you're exactly right. So what would you do? Well, you're going to distribute. Three times 2x plus get a different color here. 3 times 3. And this is equal to 15. So 3 times 2x is 6x plus 3 times 3 is 9, and that's equal to 15. So this looks more like problems that we had been working. 6x plus 9. We're trying to get the 6x term by itself. It has 9 added to it. So I do the opposite of add, I subtract. So I subtract 9 from the left side of the equation, and I subtract 9 from the right side of the equation. So what is remaining on the left side? 6x. 9 minus 9 is 0, and 6x plus 0 is 6x, equals 15 minus 9. Well, you've been doing those type problems since elementary school. 15 minus 9 is 6. So I have 6x is equal to 6. I want just plain x. It's multiplied by 6. So to undo multiplication, we divide. 6x divided by 6 leaves us with x equals 6 divided by 6 is 1. And there you have it. Another example. I have a couple of more. Example 9. Now don't freak out because this has fractions. Remember, with an equation, you can remove the fractions by multiplying through by the least common denominator. Well, what would the least common denominator be, or any common denominator? Your least common denominator is going to be, does anybody know? It's going to be 21. Your least common denominator is 21. So if I multiply the left side by 21, and I multiply the right side by 21, that should eliminate my fractions. So on the left, you need to distribute by the 21. So I would have 21 times 2/7 x minus, just keeping this minus, 21 times 3 equals, okay, right here, look at this, 21 times 1/3. 3 will go into 3 once and into 21 7 times, so I have 7 times 1, which is 7. So let's finish simplifying. 21 times 2/7. 7 will go into 7 once and into 21 3 times, so that's 3 times 2x is 6x. Minus 21 times 3 is 63. And that's equal to a 7. So we're getting closer. 6x minus 63. Again, we've got to get the x term on the side by itself. It has, the 6x has 63 subtracted from it. So to undo subtraction, we add. So we will add 63 to both sides of the equation, which gives us 6x, 63's add out, equals 7 plus 63 is 70. So we're a little closer. We have 6x equals 10. We need just plain x. So how do you undo multiplication by 6? If you were thinking divide, you're right again. We're going to divide both sides by 6. 6x divided by 6. Any number divided by itself is 1. And 1 times x is x. So x is equal to 76. Do any of those, either one of those have a common factor? If you're thinking 2, you would be right. 70 divided by 2 is 35. And 6 divided by 2 is 3. And there's that answer. Let's try one more. A bit more involved. Is there anything we can do to simplify what's in the parentheses? Any like terms or anything like that? If you said no, you would be right. Do we have any distributing that can be done? We sure do. 1/2 times x gives you a 1/2 x, and 1/2 times -4 is a -2. Because 2 will go into -4 a -2 times. Then I'll bring down the -1 equals. And on the right, we need to distribute. So 2 times x gives us 2x, and 2 times negative 1 is a minus 2. So we've cleared the parentheses. Now on the left, can I combine any like terms? We can combine a negative 2 and a minus 1. This gives us 1/2 x. Negative 2 minus 1 is a minus 3. And this is equal to 2x minus 2. Now I'm not worrying about this 1/2, this fraction over here at this point. If I wanted to get the 1/2 x by itself, I could add 3 to both sides. And I could move the 2x over, or I'm just going to leave it there for now. We've got 1/2 x, the 3's add out, and this is equal to 2x, and negative 2 plus 3, or 3 minus 2 if you want to rewrite it, is a plus 1. Now if you don't like the fraction, you can get rid of it by multiplying both sides of the equation by 2. So we'd have 2 here, and we would multiply this by 2. What is 2 times 1/2 x? The 2's are going to divide out. We have 1 times 1x, or simply x, equals, and on the right-hand side of the equation, we're going to distribute 2 times 2x is a 4x, and 2 times 1 is a plus 2. We still don't have x on the side by itself. Going to recopy this. X equals 4x plus 2. So I can move the 4x over by subtracting 4x from both sides, which gives me a negative 3x. The 4x's add out, so negative 3x is equal to negative 12. Divide both sides by negative 3 to finish getting x by itself, and this gives us x equals negative 12 divided by negative 3 is a 4. So there you have 10 examples reviewing the concepts for solving linear equations. I hope this helps.